happens. Okay, so I'm starting the recording and then we start. So today we will talk about the threads, and also maybe, let's see if we have the time, we also can talk about MVC, model view controller. Yeah, technology, we can say this way. And then approximately in 1.5 hours, you'll have the test. I'll send you the test. So yeah, then we can start with the threads. Yeah, remember I guess I already mentioned about the threads sometime. But yeah, so what's the main idea of the threads? Yeah, we already talked about it a little bit. I mean, and the concept is, I would say, it's a little bit specific, but on the other hand, I would say it's straightforward, and it may be needed in some heavy process. So the threads is not about, I would say, not about the usual execution of the program, but it is about heavy processes which may occur in the programming. So the moment. Yeah, so we have the threads. Threads, so this means actually what stands from the name is a multiple execution of actually it's execution of one program which executes its parts in multiple threads. So what does it mean? When you simply execute the program, we can say that this is one thread. But on practice, sometimes there may be such, let's say, heavy process. Like, let's say, when we run the program, it means that the program usually executes all the steps step by step at one single thread. So it means that we start, we go, and everything happens just simply one by one. On the other hand, we may have the situation, let's say, when you do some things in parallel. So let's say there is one step of program, sorry, not step, but one thread of program which does one specific set of things, and then there is another thread of program which does something else. So yeah, so what to do then? How can we actually handle this? So technically it is possible to split the program into multiple processes, and yeah, actually for a single process of environment, multiple threads are managed by means of time slice design of threads. When the time slice for a specific thread being executed, it gets over the CPU, switches to another thread for processing. Yeah, so basically some things may depend on the machine when the program is executed, but I mean, for most modern technologies, it's not a big deal. Right, but so it still remains like one execution of the program. So you still work on the same program. You just simply let's say not split, but so for one program you say, please do this in one thread, please do this in another thread, and then all these things may come in parallel. Again, the main motivation here is why and when and where do we need such such things is when we have heavy processes. So it means that one like you have really heavy process which may run for maybe several seconds, I would say, but tenths, maybe seconds. That's maybe also not really the case, but maybe minutes or tens of minutes, or even the hours. There are such heavy calculations, like if there's some really heavy task. So usually it is some kind of algorithm, maybe some kind of optimization algorithm, which needs to be implemented and executed. So, and the thing is that usually such algorithms, it's not possible to execute them in using one thread, because it may be quite heavy. But let's say we have the situation when we can split the tasks into multiple processes. So this may increase the speed of the algorithm at first. Secondly, we may have the situation when actually when the program cannot be executed at all. Like there may be some kind of maybe stack overflow, or memory issue, or like it's simply not enough resources for the program to be executed. So at the end of the day, in such cases there is no other option but to use multi-threading there. So one moment. I'm going to quickly check one thing. Just a really heavy day today. Okay. This is not a big issue. Yeah. So, and then let's quickly talk about the life cycle of the program. So at first there's the start of the program. So we started, and then we start a thread. So it means that we start a thread. The thread is running, and yeah. So basically, what we can do with the thread, we can the thread is still running, so it's not a big deal. It's not a big deal, but yeah. So basically, we may have several options. We may have wait until yeah, we can wait until the thread is over, or we can also abort execution of the thread. Yeah, so then it means that the thread is stopped and we can proceed further. Yeah, in newer versions of .NET, there are no such yeah, so the suspend and resume threads are deprecated. So it means that we should not really use them. Yeah. So how can we actually implement and use and start the threads in .NET? So first of all, we need to use the system threading namespace. So all the main threads are located there. Yeah, and basically there are two ways of implementing the threads. So the first one is that we start a thread, and the second one is sorry, we can use thread start delegate, and another option is that we use thread pool classes. So for long-running tasks, it's preferable to create our own threads using thread starts and or task class. Yeah. So, and thread pool can be used for multi in two ways. So it can be used directly using queue. Yeah, of course. Remember, since we talked about the threads, multiple threads, we can also have the queue of threads. And yeah, then at some point we may have the queue. It means that like we have the real queue, and usually there are 25 threads in the process, which yeah, so in such case, like if we exceed this number, then there is the queue and other so there are the threads in queue, and we may need to wait for them. So, and let's have an example. So let's have a quick look. Let's have a quick look here. So yeah, we here use thread start. So, and we used delegate, and so yeah, we basically use the delegate, which method we provide there. Yes, so in this case, I say that so this thread should execute one task, and then there is another thread which should execute another task. So basically, when these tasks are executed, then yeah, basically then they too are executed into different threads. So let's have a small example. Moment. So just give me 30 seconds. Moment. Okay, so let's have an example using the threads. Oh, let me create for today. So 15 of December. Then we can go to the current solution. And then let me select folder and the current one. Okay. So, and yeah, sorry for not setting Visual Studio. I was promised I'll set up it soon, but no, let me just simply copy paste it first. Side points. Name, I don't need the arguments here. Okay. So let's check same example. Maybe I'll copy paste the code from here, and let me also execute these two threads. So let's execute and see what are the results. So I'll select the current one for execution. Let's okay, so I can execute it now. Yeah, so we have such sequence. So let me maybe take the screenshot here, and then we can compare. So I have the screenshot. Then let's run it again. And let's compare the results. So you see that the result of the program is, the results are different. Yeah. So because the threads, the threads are executed in asynchronous way. So it means that there is no different which action goes first, which second, and they can simply be mixed. Yeah, and that, I mean, the result actually depends on some really, technically, yeah, we can say that the result depends on some unpredictable processes we have on our computers, like so how quickly this or that thing executes. So it's like very, I would say, very sensitive thing, and it's unpredictable. Yeah, so we can not really predict which action goes first, which second. So yeah, that's why it's not achievable. And yeah, so basically we have two processes. One process prints the action from one thread, another prints the action from another thread. Yeah, and so maybe let's remove sweeps and see what happens. Yeah, basically in this case, the thread will work the same way. Why? Because actually they're executed very fast. They are executed fast. That's why they simply go one by one. Yeah, so that's we use sweep here just because yeah, so they are executed really fast, and then simply which method is executed first, and this one prints all the actions in this case. But I mean, this is because we use sweep here. Yeah, sweep actually means that you freeze your program for some time. Yeah, so here the time is 5. I think these are the milliseconds, so it's not really important for us. I mean, it's not really significant for us, but it technically gives the program the time to to print the records in this case. Yeah, so sweep is just simply used for the testing purposes here. Okay, yeah, so basically start thread and then threads are executed. Do you have the questions about this? Okay, no questions, so then we can proceed next. Yeah, so again, here's the way how the delegates are used. So we basically delegate the method next to the thread. Okay. So we may have different outputs. Yeah. So then let's have a look on what can happen if there's the thread start delegate used. So in such case, we're going to create the task. We pass the task to be processed. Here, then the thread is created, the thread is started, and yeah, so we can check if the thread is still alive. If it's not, yeah, so it means that the thread is still executing. We can test it. So the threads are actually the objects, yeah, so you can deal with them as with the objects, check some parameters and test something you want. Yeah. So and yeah, so this is about it. So using the thread pool class, so you can you can invoke method first, and then you also the thread will run. So, and as an addition, you can also use the tasks, and you can use wait, for example, to wait until the task completes. So, for example, it means that but this means that if you execute this method, quickly need to reply. I'm sorry, just today is quite a heavy day, so. Okay.
For me too, maybe it's something global.
Sorry?
I said for me too, it's a difficult day, so maybe it's something global.
Uh, yeah, I mean, just accidentally too many things in parallel going. And yeah, so it's just yeah. So okay, we can proceed. We can continue. Um, so yeah, so there is so the tasks we can execute. We can pass the function to the task, what needs to be executed, and then it goes to another task. Then it goes to a task. Yeah, so we can split again similar way as with the threads. Yeah. So here's again the example. We can run the task, and yeah, we can also attempt to read the result box going right until the task is finished. So in this case, it's not synchronized. So also it can be task with continuation, like we have one task, continue continue with another task, so we can define the steps step by step to be executed. Yeah, so this, or we can simply define the queue this way. Yeah, so, and yeah, we can also access the previous task. So it means that we have one task, then we have the next task, and so yeah, like in this case, we see there's the task is executed, it returns the result. Then the next method in the queue here, so the next task in the queue, it takes the result from the previous and then writes it, yeah, basically it writes at the end. So basically we can create the queue and pass the result from one method to another actually sequence by sequence, step by step. Yeah, so one thing what we can also use is so-called asynchronous programming. So the definition is quite simple. It means that when you have asynchronous, simply if you don't use the threads and you have asynchronous method, then there is no actual difference for your program. So if you don't use any threads, it will execute the same way as before. Yeah, but what's the thing? The thing is that when the asynchronous thread defined as asynchronous uses the threads inside, then it means that we can call await and wait until this method is until all the threads there are executed. So here we have this download content asynchronous, so it means that it will wait until basically until the threads are executed in this case. So this is the signal to the compiler, so compiler will understand that we need to wait in this case, and it will not finish the execution. It will wait until it finishes the execution. It is also really important in the web programming. So if we usually deal with some kind of requests, HTTP requests, so again we sending the data in between the components of the website or web application. So some asynchronous programming may be needed there. In addition, let's talk about the races, about the race condition in the multi-threadings. So in general, it is normal for one thread to use the data of another thread. So in such case, there will be a scenario when two or more threads will race to reach the code for walk first. Because again, the thing is that we still execute the same program, but in multiple processes. But all these processes may in theory work with the same object. With the same object, and then the thing is, so do we really know which object when to be executed? So for example, let's say we have a static object. So let it be, let's say, double my number or something like that. So let's say it starts at 1, at 0, for example. and then let's say two threads uses this particular object. So here let's say I increment it, and here let's say I multiply it. So, and let's see, let's say we want to, let's see what the result will be here. So, yeah, in theory, okay, maybe let's not wait on this time, just print the result. Okay. So in this case, we may see that we may get different results. Yeah, so both threads uses the same. They use the same element. Yeah, so here we see the result is 5. Let's execute. Same program. So here we see the result is actually 6. So we may have also different results depending on, yeah, actually this is why it's called the race. Here we don't know which program, sorry, not which program, but which thread accesses the object first. Yeah, so in this case, I mean, we don't know, and the first reach.
We could maybe print out each time and take a look at this.
Yeah, we can also print. That's a good. This is a good suggestion. Yeah, maybe let's print. Good point. Yeah. So in this case, we see this result. So at first, yeah, in this case, we don't know which thread is executed because we start at 0, and if we try to multiply 0 by anything, it will still be 0. So in this case, maybe to make it more interesting and clear, let's maybe start at, let's say, 2 maybe, and because 0 times anything is 0. So in this case, what we see that at first it starts. This case, it is interesting why it printed 3 2 times. Oh, okay, maybe I got it because this one was printed. Yeah, this is interesting because this one was printed before these threads are all. So that's, I think, also is an interesting thing, because you see that, yeah, actually in this case we see that we have 3 threads. In fact, yeah, we have 3 threads. So the first one is the main thread, which also, yeah, we can, and in this case we see that the first one is executed. This one, yeah, it is incremented and printed. Then the second one is this one, then next it goes to this one, then again this one, then this one, then this one, then this one, then again this one, then this one, then this one, and then this one. Yeah, so you see that the sequence is quite chaotic, and we cannot really rely on which one is first. And especially if they deal with the same object, then it may trigger some issues there. So yeah, do you have any questions about this? This is the way how the races work here. Yeah, so.
What about practice? Where these threads are installed in such implementation are used in practice?
What exactly you mean the parallel? You mean the parallel threads and accessing the same?
I think that's such example like you showed. So in real life.
No, I mean in this case, of course, we don't calculate such data in real life, but so maybe in this case, maybe I cannot really provide.
Or it's only for example to understand
I mean,
how
yeah,
there's.
this one is for example, but on practice there may be such objects which may be accessed from multiple threads. For example, let's say you put this some kind of collection. So you need to add the elements to the collection, and you add them from different threads. And so in this case, you simply collect the data, or in this case, the information or something like that from multiple threads. Like you collect the data from one thread, from another, and so on and so on. So you simply grab everything from multiple threads. In such case, you can access the objects from different threads and put, let's say, what you need there. Yeah. But in this case, you may need to have the shared object like yeah. So what I just said, you have, say, the collection, the list, and let's say this would be the list of doubles. My list. No, thank you. And you can, let's say, add the elements there. Actually, my list. So in this case, I just add the random element. I mean, on practice, let's say you may need to add the real element, some kind of needed elements. Yeah. So in this case, it's just for example, and at the end, you may do something with this list. Yes, you may need to take the information from the list. So and yeah, so this is how it can be used. Yeah. Where it is used, I mean, somewhere when you have some kind of heavy processes, I mean from the time-consuming processes. Yeah, so in such case, I mean, this can be web process, like you need to send something to one place, then get something from another place, and so like you don't need to them to be executed like step by step, and yeah, in such case, you may need to use multiple threads. Yeah, so, but again, I think it's also quite specific, not quite specific, but something you may actually, it depends on on the field you work in. So maybe you work in the area where there are lots of such heavy processes, and then you always, not always, but maybe you quite frequently need to use the multi-threads there. On the other hand, you may have a situation when it's not needed at all, for example. Yeah, and so it depends where on which area you work. Yeah, so I mean, I personally did not really use threads in my experience a lot. Yeah, so there were some say a few, like one or two cases when I had a heavy data calculation, like it was really heavy. One it was not enough for one thread to process all these calculations, and that's why I used multiple threads. But I mean, on usual practice, it's maybe not really needed. Yeah. So this is just such example. Okay. So do you have any questions? So hope it's a bit more clear. And yeah, so this may be challenging. I mean, if multiple threads access the same object, it may be challenging just simply because um, the behavior may be, let's say, quite sensitive. Like in this case, one thread depends on another thread, and they can access like the values of this object, the value of this object may be impacted from multiple threads. Then the results for the executions can be different. And of course, as you've seen like this, I mean, on practice, this may trigger some serious issues. And so about this manipulation. Also, race conditions, they not only give you unexpected results, as we had here, but also provide different outputs at different points in time. Okay, so the result may be unexpected, and this is what we definitely don't need to do. But how can we actually fix this situation? So we can use lock. So we can use lock, and so what does it mean? That it means that the object cannot be accessed until it is unlocked. So in this case, it means that the object is locked, so it will not be. So it means that we need to execute this. The execution of this particular process needs to be finished first before we can access this thread. Before this object can be accessed by another thread. Yes, so I can take a look on our example and see what happens here. Maybe I will not back to the list now, but I will stick to the previous example maybe. So maybe I'll make this. Yeah, so let's say we lock the number here. Yeah, okay, yeah, it's only then, yeah, it can only be used for the reference types. So then let's maybe have one input point. So let me create maybe another class and lock double here. So let's say that would be my double or something like that. So this is just the workaround. So can we access here and say we public integer, say number, and then we can let's maybe also create the constructor double. So that will be public double, and I can set the value from here. But this is just a workaround, yeah, so it's not it does not really affect our tasks. This task. So let's do it this way. Oh yeah, sorry, I think we should have double. Let it be 2 maybe. Alright, so in this case I can access not number but my number, and in this case the thing is that now my double is the reference type. Yes, so double itself it's not the reference type, it's value type, but my double actually is the reference type. So then I can write it and I can access it as well. So in this case I don't need to lock number as well, I will lock simply my object. Okay, so in this case let's see the result. Yeah, so what happens here? At first it it prints 3, but then we see that it adds 1 here, and then the object is locked, and then it's not accessed until it is released here. Space and numbers. Let's have a quick look here. Yeah, so here we have the object, and then yeah, so you see here the thread starts, thread 1, which is upload starts. Then it is executed 2 times, and then the next one is executed. So the corrected output in this case, it would be 10, because the lock is released after this, and then yeah, the object is free. It can be used next. Okay. So, and yeah, we may also have the scenario when there are the deadlocks. So it means that one thread is waiting for another thread to release the lock. So it means that simply we have this, let's say, endless loop of locks, and it means that so basically when each thread is waiting for a lock to get released, the situation then is turned into deadlock. So it is one thread, it's not releasing a lock because it's waiting for a lock 2 to be released, and lock 3 to be released, the thread 3 waits. Thread 4 to release the lock, and so on and so on. So in this case, we have the deadlock situation. Okay, so this need to be careful here. So for example, here we have, let's say, two static objects. There's the main method which locks the second thread, second lock, and second object. It's executed and then it locks the first object. First lock. Then then there is another thread which also locks the first object and first lock, and then we have this deadlock. So yeah, this is about the one, because they use the threads again. Key point here is that threads use the same data set, the same set of data. So it means that if they access it, then we normally lock it before. So then before the lock is released, the data can be accessed by another thread. Okay. So, do you have any questions about the threads? It was sort of a bit, I would say, quick topic, but yeah, that's just mostly that's the important one. Are there any questions? Yeah, so the key usage here again is some heavy processes, and so what do I mean by saying heavy process? I mean, it depends. Usually you see from practice when something works really slowly. Yeah, so again, in theory, you have two processes which, let's say, executes one process which is executed like for 1 minute, or so, yeah, for example, for 1 minute. Then in theory you can spread it into, let's say, two processes, and this may, I'm not really sure if this will execute for each half a minute, but it will definitely be faster if you split it into multiple processes. So this is what makes your program faster, normal way. And again, as I said, sometimes there may be some memory issues, so the threads also help there. Okay. Do you have any questions? Yeah, so also the question is about the previous home task about the databases. How was so any successes there, any achievements? So I see Irina sent the results. By the way, Irina, have you managed to fix your issue with the version? Or
Hi, no, as I wrote, I'm afraid to install this 22 version for Visual Studio.
okay,
as
but,
I'm, yeah.
But can you maybe share your screen? What was the error you had? So maybe, if possible, can you maybe share this? So Irina, can you share your screen if possible?
Yes, 1 moment.
Yeah, sure. can you execute this one?
Hello.
Yeah.
I just got my microphone was
Yeah.
muted. Yeah. So basically, here's the code. We fix the issue with database name, and maybe you can check what is regarding hump. It's located on here on my computer. So I need to press hump start, I guess, right?
You can simply run examp from the program. So on the web, you can type examp and open
Okay.
as the application.
Yeah, and here it basic. Yeah, okay. The question is, don't I need to open the database also somehow?
Can you maybe show example once again?
This one?
No, example.
Yeah. So I press start. I'm just checking if I'm doing everything correctly.
No. Please run from. No, don't run it as a console application. Just please pause this. No, you don't need to run
One
it from
moment.
here. Just from the applications. Please pause. Yeah, this one. Okay, so it's
This one.
running.
Yeah.
Yeah. Okay, so it's running. Then. So okay, so you have the localhost here. This is fine.
This is database computers.
Yeah.
Yeah, and I think this is interesting as I guess I don't know how to save the table, or I don't understand how to.
No,
You
I
say
mean the table is correct.
it's fine.
Yeah,
Okay.
the table is saved. So you try to access to computers. Okay,
Yeah.
can you show maybe the code?
Yeah. I will maybe make it smaller. I'm not
No,
sure.
it's fine. It's fine.
It's fine.
Yeah, it's fine. Then when you can you go down when you try to connect them?
Yeah. Yep. Here.
So yeah, you have the computers. Okay, connection is correct. Okay, source localhost. Let me double check what did I have here, just for double check. So that was this one. Okay, so data source localhost, the database. Can you maybe show once again the database?
Yeah. One moment. Here.
Okay, computers. So this looks correct. Okay. Okay. Then can you maybe go to the okay, to the main example again? Open the users. Yes, because sometimes you may have different privileges for the users. So can you open? Can you open the privileges? Oh, so you have user accounts. Sorry, user accounts. Yeah, this one. So you have the root localhost, no password. Okay, grant yes. Okay, this seems to be correct. And okay, then to the database if you go there. So then, yeah, so if you check privileges here, okay, for the root localhost, can you maybe edit privileges for root localhost if possible, please? The third one, yeah.
Yeah.
So you have grant, yeah, basically have grant. Yeah, so then this is. So, and if you run the program, it shows the error you had, right?
Yes, basically, one moment. I will run it again. I think here down, he's write something regarding these versions, but it actually didn't ask for a larger version. I'm using NET-5, but I think it was something regarding other versions. But to be honest, I don't see this now. Um, mhm.
Hmm. So this looks, okay, this looks a little bit. So can you run again, maybe?
Yeah, I will maybe rebuild and
I'm not so sure if it does.
uh,
So you have no result, right?
yeah, yeah,
Okay.
exactly.
Can you now go to the database, maybe?
Mm-hmm. Да.
Okay, but in this case, you didn't get the error, right? So in this case,
Yeah.
okay, maybe let's see if you have any results there. So go to the database table.
This one.
Yeah.
Mm-hmm.
So the logic, okay, but it's empty. But you see, you don't have the error, so it means that the connection was established, right?
Oh, okay.
So
So basically, what was I think unclear? I created a table with just the name of the how to say the name of the columns,
yeah.
right? And maybe it didn't save properly or something like that because it looks like there is no table actually at the moment, right?
No,
Or
there
no?
is the table. You have ID,
Ah,
name, developer. So this is the table.
okay.
So you can go to SQL, for example, now, or maybe you can yeah, you can go to SQL. You can write any queries here. And so table is in place.
So actually there is
I mean, this is selection query, so you can prepare the query here, like select, insert, any SQL query you want. You can prepare it from here.
just like some kind of data, I don't know,
Yeah,
example.
so just SQL
Yeah,
query. We
okay.
may maybe maybe we can have a deeper look on SQL queries tomorrow. I would say that.
Okay. Yeah.
So we can take a look on SQL. Remember remember SQL is you. But so you go again to go to the browse first. No, browse, yeah, the first one. No, I mean the view, structure, browse, search, yeah.
Yeah. Okay, one more.
So, yeah.
Mm-hmm.
So and yeah, so the table is here. You can also press insert, so you see in the middle.
Yeah.
Insert and try to add some values from here. So just maybe some random.
A random example.
Yeah.
Oh, um, так. Mm, mm, mm. Text. So basically, I can just save this one, right?
Yes. So just some.
Int
Yeah, of
ID.
course, the integer one. Oh no, the ID you can skip ID. Hold on. Yeah, okay. I mean, in this case, you may need to add it.
Just
Yeah,
maybe better.
yeah,
And go.
yeah,
Yeah.
yeah.
Mm-hmm.
Scroll. Yes. So
Mhm.
okay. So this
Так.
is you can run this query. So we press go on the right side.
Mhm.
And so you now inserted the one. You can go to browse now,
Yes.
and you see the entry. There are two entries.
Mhm.
So yeah. And yeah, one more thing. If you go to structure. That's the one. I see you have not done two things in structure.
Yeah. Okay.
Structure. Structure.
Mhm.
Second one, yeah. So you need to. So you can now. You go to increase tick on ID. First one,
Yeah.
and then so on the bottom you have primary. So you need to. Yeah. So you can primary one down. Go down. So you have down. So you have primary on the middle. In the middle,
Uh,
primary. No, I mean in the middle of the screen, in
okay.
center.
I
Primary,
see. Yeah.
primary key. Yeah.
Okay.
So
Okay. Yeah.
so you set up. Yeah. In this case,
Yeah.
you need to delete the data first, and then
Mhm.
set it as the primary key. And one thing, you also then can press on change. So you can press on change. So once you delete the data, you press on change on the in action
Mhm.
and the ID
Yeah.
on the
Safe.
next
Yeah.
in the ID not this one. You need to select the column, yeah, or you have also on the right. But yeah, so here you have AI on the middle, yeah. So this
Yeah.
one AI, it means automatically increment. So when you select this as a primary key, you also I suggest you to select this because this means that every time you add new entry, this ID is automatically incremented for the next entry. So it means that ID is added automatically. So if you add the first entry, this will be 1. When you add the second entry, this will be 2, and so on and so on. So this will automatically be incremented, and it means you don't need to add to generate this ID by yourself. So it will automatically be implemented. But I think again, yeah, about the SQL we can discuss in more details tomorrow, maybe, because we have more time, and it's also, yeah, also we can discuss wider about this. Okay,
So I can just press save.
and this you can try, but I think, yeah, I mean, yeah, you can press save, but in this case, I said first you need to define it as you need to delete the data in your case and define it as
Yeah.
primary. That is just
And define it as what?
primary key. Yeah, this one. Yeah,
Primary key.
but
Mhm.
first you need to read the data because you have two duplicates and then it cannot be primary. But again,
Mhm.
maybe more details we discussed than this.
Okay.
Then yeah, so
But my question was,
yeah,
wasn't it in your example like that, that for you something printed out because it was read from this XML file? or it's not works like that?
No, I mean you need to print.
No.
You need to execute print command if you want to print something.
Yeah, it makes sense. So
Maybe I had some print somewhere, but
yeah, might be the
yeah,
case.
might be the case. Yeah.
Yeah. Okay, then thank you.
Okay. Good.
Yeah.
Any other questions from anyone? Okay, then I think I can, as usual, share the test with you, and you can then proceed with the test. And in case you have any questions, you can ask me just as usual. Yes, so it's a small test this time, but maybe with more, not really more advanced, but some maybe not a bit tricky questions. So then I'm sharing it with you, and then let's proceed as usual. We can maybe close the session now, and if you have any questions, then you can reach me in chat. Right? So again, the deadline is maybe, so you can also send me tomorrow morning, so it will also be fine. So no rush, no stress. So do it your and then yeah, I check it this weekend, and then we discuss all these details on Monday then. And yeah, tomorrow we then discuss a little bit about SQL, and also we start then talking about model view controller as well. Okay, any questions? Okay, then if not, please then proceed with the knowledge check, and then meet you all tomorrow then. Okay, so any questions, please let me know, and then yeah, please proceed. So thank you for finishing the session, and then meet you tomorrow then.
Thank you. Bye bye.
Okay.
Bye.
Thank you. Bye.